Alright, in this video we're going to be looking at reciprocal trig functions. And the three reciprocals that we're going to deal with are cosec, sec, and the cot of any angles. And each of these, you would have never seen them until very recently, until now, but they actually are related to sine, cos, and tan. Cosec of theta is the same as 1 over the sine of that same angle, so 1 over sine theta. Sec theta is the same as 1 over cos theta, and therefore cot of theta is 1 over tan theta. And a very easy way to remember which one is which, as in which one of these is 1 over sine, 1 over cos, and 1 over tan, just look at the third letter of each word. Okay, the third letter is S, so it's 1 over sine. C, 1 over cos, and T, 1 over tan. Okay, let's have a try of these four questions first. And our goal here is to work out the exact value for each of these trig ratios. So the first one is the cot of 3 pi over 4. And you should have your exact values memorized between 0 and 90 for sine, cos, and tan, because that will really help us here. So for the first one, we can say that cot is really just the same as 1 over tan. So we can do 1 over the tan of, so it's the same as 1 over the tan of 3 pi over 4. Okay, it's 1 over tan because that's what cot is. And what was the tan of 3 pi on 4? Okay, and if you're still unsure of how to work out tan 3 pi on 4, draw a unit circle and identify which quadrant 3 pi on 4 is in. And I know 3 pi on 4 is in this quadrant here. Okay, and we know that this angle from the positive x-axis is what's 3 pi on 4. But what is the reference angle with the x-axis? What is our acute angle with the x-axis? It's pi on 4. So let's work out what is the tan of pi on 4, and you should have this memorized. The tan of pi on 4 is simply just 1, but now we need to check which quadrant we're in. We know that in the second quadrant, the values for tan of any angle in the second quadrant will always be a negative number. So in this case, the tan of 3 pi on 4 is simply just negative 1. Okay, so that means we can say this is the same as 1 over negative 1, or simply just negative 1. That's what the cot of 3 pi on 4 is. Okay, let's look at the next one. The next one is the sec of 5 pi on 6. Okay, so the sec, is it 1 over cos, 1 over sine, or 1 over tan? Well, if we look at the third letter, we know it's 1 over cos. So 1 over the cosine of 5 pi on 6. Okay, now we need to work out what the cosine of 5 pi on 6 is. Okay, so quickly draw a unit circle, identify the angle of 5 pi on 6, and I know that's roughly in the second quadrant over here. Okay, where this angle here is 5 pi on 6. And then our reference angle, the angle with the x-axis that's acute, is pi on 6. So now what we do is we recognize what is cos of pi on 6. Okay, this is our reference angle. We know that the cos of pi on 6 is simply root 3 over 2. But is it positive or negative root 3 over 2 because we're in the second quadrant? Well, only sine is positive in the second quadrant. So the answer for this is 1 over negative square root 3 over 2. Another way of saying 1 over a fraction is simply just the reciprocal. So the answer to this is minus 2 over root 3. Okay, and that is what the answer to sec of 5 pi on 6 is. Okay, next one. What is the cosec of 13 pi on 6? Cosec of 13 pi on 6, the third letter is an S. So that's the same as 1 over the sine of 13 pi over 6. So now we need to work out what is the sine of 13 pi on 6. Quick unit circle, 13 pi on 6 is roughly here. Okay, because this angle all the way around is going to be 13 pi on 6 radians. But what is our acute reference angle, this angle here? Well, we know that angle there is simply just going to be pi over 6. So let's work out what is the sine of pi on 6. The sine of pi on 6 is a half, we know that. But we know that the angle 13 pi on 6 is in the third quadrant. And remember, A, S, T, C, we know in the third quadrant, only tan is positive. So that means sine will actually be negative. So that means our answer to this one here is simply the same as 1 over negative a half. And in this case, this is just the same thing as negative 2. Okay, so this is our answer to question 3. Question 3 is simply minus 2. Okay, and lucky last for this set of questions, let us work out what is cot 7 pi on 3. So cot 7 pi on 3, the third letter is a T, so we know it's 1 over tan. So 1 over the tan of 7 pi on 3. Okay, let's do the same thing again. Let's sketch it out. Okay, if we sketch it out, we know 7 pi on 3 is roughly going to be over here. Okay, it's really just the same thing as the reference angle of pi on 3. okay, because all the way around will be 2 pi, which is 6 pi on 3, and then we've just added an extra pi on 3. So now we need to work out what is the tan of pi on 3. And the tan of pi on 3, you should have it memorized, is really just the same as square root of 3. And because we're in the first quadrant, we know that all sine, cos, and tan are positive in the first quadrant. So that would mean that root 3 is really just the positive root 3. So it means this is equal to 1 over the square root of 3. But if we want to keep our answer fully rationalized, we can say it's the same as 1 over root 3 times root 3 over 3. Root 3, sorry. That's the same as root 3 over 3. This is your final answer to question 4. Okay, these are our next 3 questions. This time we're going to do the exact same thing, but just in degrees. Okay, so let's start with the first one. The first one is the sec of 225 degrees. Third letter is C. Okay, so if you want to work out what this is, it's the same as 1 over the cosine of 225 degrees. Okay, so now that we have this, draw out a quick unit circle. Where is 225 degrees on a unit circle? Well, it's in the third quadrant. Okay, because we're measuring it from the positive x-axis this way. So 225 degrees is over here. So now that we have this, what is our reference angle? Well, not to scale, but our reference angle will be 45 degrees. So now we need to work out what is the cosine of 45 degrees. Okay, and the value for that is root 2 over 2. But which quadrant are we in? Are we in the first, second, third, or fourth? Well, we're clearly in the fourth. So, sorry, we're in the third quadrant. So if we're in the third quadrant, is cos is that positive or negative in the third quadrant? Well, A, S, T, C, only tan is positive here. So that means cosine will be negative. So that means the answer to this is simply going to be equal to 1 over negative square root 2 over 2. And that's just the negative reciprocal. So we can just say the final answer to this is negative 2 over root 2. Or if we rationalize, we can times the top and the bottom by square root 2, in which case we get negative 2 square root 2 all over 2, which is just equal to negative 2. So that is the value for the sec of 225 degrees. Okay, now let's look at the next one. The cosec of 300 degrees. Okay, because the third letter is an S, we know this is the same as 1 over the sine of 300 degrees. So let's work out what the sine of 300 degrees is. We'll draw it out. 300 degrees is in our fourth quadrant, roughly over here. Okay, and with the reference angle, it's always with the x-axis, is this one here. Okay, so our reference angle is going to be 60 degrees, because all the way around like this is 300. Okay, so let's work out what the sine of 60 degrees is. The sine of 60 degrees is root 3 over 2. And because we're in the fourth quadrant over here, the fourth quadrant means that sine is actually negative, okay, because only cos is positive in this quadrant. So that would mean we're going to use the negative version of this, in which case this is the same as 1 over negative square root 3 over 2, which is the same as negative 2 over square root 3. And if we times both the top and the bottom by square root 3, just to make it rational, this is the same as minus 2 square root 3 all over 3. Okay, and that is your answer to question 2. Lucky last, we'll do cot. Okay, what is the value for cot in this case? Third letter is T, so that means it's 1 over tan. So 1 over tan of 240 degrees. And this here is the same as, well, first we need to work out what tan 240 degrees is. So unit circle, 240 degrees is in our third quadrant over here. Okay, and it has a reference angle of 240 degrees. Sorry, no, it doesn't. It has a reference angle of 60 degrees. The 240 degrees is from here. All the way around to here is 240, but the angle with the x-axis is 60 degrees. So now let's work out what is the tan of 60 degrees. Tan of 60 degrees, if we have it memorized, is simply just root 3. But is tan in this quadrant positive or negative? Well, in the third quadrant, tan is actually positive, okay, because it's A, S, T, C. So T is actually positive in this quadrant. So now what we can do is we can simply just write 1 over the square root of 3. And that just simplifies down. If we times the top and bottom by square root 3, that simplifies to square root 3 all over 3. Okay, this is our next question. Okay, our goal is to solve for the angles of x in each of these questions. Okay, so let's give it a go. We'll start with question 1. Whenever we have reciprocal functions, it's very nice to rewrite our equation in terms of sine, cos, and tan. So because we know cosec, the third letter is s, we can simply rewrite this as 1 over the sine of x. So 1 over the sine of x is going to equal to 2. And if we just rearrange this equation by swapping the 2 and the sine x, or just timesing both sides by sine x and dividing by 2, we get that sine x equals to a half. Okay, and we're solving that between 0 and 2 pi. So the values for x here, in the first quadrant, we know that sine is positive. If we draw out a unit circle, ASTC. So sine is positive in both these two quadrants. So now we just need to work out the reference angles for which sine is equal to a half. We know that sine of 30 degrees, or pi on 6, is equal to a half. So now we need to work out what is the angle in the second quadrant. If this angle is pi on 6, okay, the angle from the x-axis like this is simply going to be 5 pi on 6. So the second answer here is 5 pi over 6. And these are our two solutions between 0 and 2 pi. The next one is the sec of x is equal to plus square root 2. So again, we're going to rewrite this equation so that we have a sine, cos, or tan. The third letter here is c, so that means it's 1 over cosine of x is equal to minus square root 2. I did that by moving this to the other side by minusing square root 2. Okay, so now we can rearrange this and say that cosine of x is equal to a negative 1 over square root 2. And negative 1 over square root 2 is the same as negative square root 2 over 2. So now let's check. Which quadrant is cosine going to be negative in? Okay, in our unit circle, ASTC. Okay, so cos is actually negative here, and it's negative here. So it's negative in the second quadrant and in the third quadrant. So now what is the reference angle that will make cos of x equal to root 2 over 2 in the first quadrant? In the first quadrant, we know that pi on 4. Okay, so the cos of pi on 4 is what makes it equal to root 2 over 2. So now what we need to do, we know the final angle has to be in the second and third quadrant, but we just need to work out what is the actual angle in these two quadrants that'll make it such that our reference angle is pi on 4. Okay, so we need to work out two angles. What is this angle here? And what is this angle here? Well, this angle here is simply just pi minus pi on 4, which is just 3 pi on 4. Okay, so that's one of our answers. And our second angle is from here all the way to here, which is just pi plus pi on 4. And that'll give us 5 pi on 4. And that is the solutions to this equation here. Okay, x is equal to 3 pi on 4 and 5 pi on 4. Now let's have a look at the last question. Cot of x equals root 3. So again, the third letter here is going to be a t. So it's 1 over the tan of x. Okay, that's equal to square root 3. But we're going to rearrange this for tan x. So tan x is simply going to equal to 1 over square root 3, which is also equal to root 3 over 3. Okay, so this one should be a little bit easier. What angle of x makes the tan of that angle equal to square root 3 over 3? If you have it memorized, you should know that x is simply going to equal in the first quadrant to pi over 6, or 30 degrees. But now we need the unit circle to work out the other one. So tan of some angle is a positive value. And tan is positive in both the first quadrant, okay, because all of them are positive here, and in the third quadrant. And we know that in the first quadrant, the angle is going to be pi on 6, the reference angle. So that means the reference angle must also be pi on 6 in the third quadrant. But what is this angle measured from the x-axis all the way around? It's simply going to be pi plus pi on 6. Okay, and that's the same as 7 pi on 6. Okay, very straightforward, and that is how you solve these basic reciprocal equations. Okay, this is our next question. I'd like you to pause the video and give it a go yourself first. Okay, so let's first recognize that tan of theta, if that equals to this, we can simply draw a triangle. Okay, we can draw a triangle where the inside angle is going to be theta, and it's a right angle triangle. And we know that the tan of this angle in this right angle triangle is simply going to be the opposite over the adjacent. Okay, that was one of the first things you learned about the tangent of an angle. tan of theta equals to the opposite side divided by the adjacent side. So in this case, we know the opposite side is -7 and the adjacent side is 24. So now using this triangle, let us now work out what the hypotenuse is going to be. So using Pythagoras, we can say that 7 squared plus 24 squared is equal to x squared. That's our missing side x. So that means x is going to equal to the square root of all of this, and what we get is 25. Okay, so that means the final side length is actually just 25. Cool, so now we have this triangle. Let us work out what the cos of theta and the sine of theta is going to be. Well, the cos of theta is simply going to be the adjacent side divided by the hypotenuse. Okay, we know that cos theta is adjacent over hypotenuse. So that means it's simply going to equal to 24 over 25. But we have to be very careful. Okay, which quadrant are we in here? We're in the third quadrant, because if we draw out a unit circle, if we draw out a Cartesian plane, 3 pi on 2 is 270 degrees. Okay, that's over here. And then 2 pi is over here. It's all the way back around here. So what we're saying is if we're between 3 pi on 2 and 2 pi, we're actually in this quadrant here. We're in the fourth quadrant. And we know that cosine is the only ratio that is positive in the fourth quadrant. So it makes sense that cosine of whatever the angle theta is, we don't need to know what it is, but cosine of angle theta makes sense that we get a positive number like this. So now let's do the exact same thing with the sine of theta. So we know, according to this triangle, the sine of theta is simply going to be the opposite over the hypotenuse. And in this case, we have that the opposite is -7. Actually, we don't even need the negative was just symbolic. Okay, we can say it's 7 over 25. Okay, because it's the same as opposite over the hypotenuse. But in the fourth quadrant, okay, didn't we just say that cosine is the only ratio that's positive? So that means the value for sine of theta in this case is going to be negative. Okay, we need to have this negative because in the fourth quadrant, only cosine is positive. And that's how you solve this question here. The answers to this question are sine of theta equals -7 over 25 and cos of theta equals 24 over 25. Okay, and the last question here. Okay, if tan theta is going to equal 4 over 3, and we're in between these two angles here, so i.e. if we draw it out, okay, we're between pi and 3 pi on 2. So we're going to be in the third quadrant. So if we're in the third quadrant and tan of theta equals this, we need to work out this expression over here. So the first thing we're going to do is we're going to work out what is the sine of theta, what is the cos of theta, and what is the cot of theta. Okay, so let's first do that. We can work out the cot of theta very easily. Okay, the cot of the angle is the same as 1 over tan of that angle. And we know that tan theta is simply equal to 4 over 3. So that means it's 1 over 4 over 3, or just the reciprocal, which is going to be 3 over 4. So that's what the cot of theta is. To work out what the sine and cos is, I'm simply going to draw a right angle triangle. Okay, I'm going to draw a right angle triangle with the inside angle of theta. And they've told us if tan of theta equals to 4 over 3, and we know that tan of an angle is going to equal to the opposite side over the adjacent side. Okay, SOHCAHTOA. That means the opposite side is 4, and the adjacent side is 3. So let us now use this triangle to work out the hypotenuse. Okay, to work out the hypotenuse x, it's the equation of Pythagoras, 3 squared plus 4 squared equals x squared. That means x is simply equal to the square root of all this. So that means x is equal to 5. Okay, so now that we have this, let's work out the sine of theta. The sine of theta is simply the opposite side over the hypotenuse. So in this case, it's 4 over 5. And the cos of theta is going to equal to the adjacent over the hypotenuse, which is 3 over 5. But we have to be very careful. Okay, because we are in the third quadrant, okay, we identified we're in the third quadrant, only the tangent of an angle in the third quadrant is positive. The sine and the cosine will actually be negative. So let us just alter this a little bit to put a simple negative in front of both of these. And that's how you work this out here. So let us now evaluate the actual expression. To evaluate this expression here, we're simply just going to sub in the sine of theta, the cos of theta, as well as the cot of theta. So let us now do that in a different color. So this is really going to be the same as -4 over 5 minus 2 times the cos of theta, which is 3 minus 3 over 5, all over the cot of theta, which is 3 over 4, minus the sine of theta, which is minus 4 over 5. So let's now evaluate this. So on the numerator, we have minus 4 over 5 and plus 6 over 5, all over 3 over 4 plus 4 over 5. On the numerator, we can simplify it down as 2 over 5. And on the denominator, we can work this out by making it a common denominator, times the top and the bottom of both these fractions by 5 over 5 and 4 over 4 respectively. So what we get is 15 over 20 plus 16 over 20. That'll give us 31 over 20. Another way of saying dividing two fractions is multiplying the reciprocal of the other one. So keep the first fraction, times it by 20 over 31. We can do some cancelling. 5 and 20, we're left with 4 here. So our final answer for this equation, okay, the final expression is simply whatever 2 times 4 divided by 31 is. So that's 8 over 31. Okay, and that is how you work out this expression here using the reciprocal identity.